Hello, this is KTaNE, and this is a tutorial of another member of KTaNE Russian server, Play. This module provides a simple solid background of violet and a play icon and seed, which resembles base 64 characters, and a number that represents the move number. So let's start solving the module then. So first of all, we need to convert the seed to binary, which we can do by doing these steps. So first of all, we need to add up 1 if the starting sign is plus, or 0 if the starting sign is minus. So we're starting with 1, and then we will just add up the following binary digits to this string. So we have capital Charlie, lowercase whiskey, shut up Megam, lowercase Romeo, capital Charlie, lowercase Romeo, 7, capital Mike, capital Charlie, lowercase 3, and lowercase 6. No, sorry, just number 6. That's what I meant. Alright, now that we have our base 2 seed, we need to understand how this module works. So we currently will press each button twice, and each button will split up into 4 buttons. So the big button will have 4 child buttons, and each one of child buttons will have 4 child ones again. So total amount of buttons will be 21. And each button will have starting move and ending move. You must press every button twice on both moves. So for example, if the move number will be 2, 4, that means you need to press first on 2 and then press it again on 4. The current move is displayed on the screen, as it says, and it can be incrementing by fast forward button. So starting off with the big button, it says the starting move of the big button will be always 0, which means we can just insert a 0. Then we're going to take first 2 bits out of seed and treat them as one number. So we're taking 1, 0, and we need to convert it into base 10, so that's 2, and add 1, 3. So, and then we add it to the starting move of the button, and this is the ending move of the button. So our starting and end move of the big button are 0, 3. We can check this by pressing the play icon on 0, and then skipping, and then pressing on 3. You can see it will divide itself by 4, and then we need to do it again, but more weird, let's just say. Okay, the next step, we need to get 5 next bits, and then we need to look up in the table for a corresponding list. We need to add up numbers of the ending move of a parent, so that will be a 3. Let's take our moves, as you can see, this ones, and then we're going to apply start of children, which means we have 5, 7, 4, 6. Alright, and this is it. This will be our starting move of child buttons in Ring War. Now we'll take next 8 bits. So this is 4, 5, 6, 7. So this is 8. We will divide them into pairs, so like this. And then we'll do the same process in step 5 for every button. So what it says, we need to take first 2 bits, and then treat them as one number, convert it to base 10, add 1. So that means this is 3, 2, 2, 3. Add 1 to each, and then add simultaneously to each button relevant. So 5 plus 4 will be a 9, 7 plus 3 is a 10, 4 plus 3 is a 7, and 6 plus 4 is a 10. So these are starting and ending presses of each child button. Now we need to determine for the next 4 buttons that will come up after each play button. That means we need to take 20 bits which means, so that's 5, this 5, this 5, and this 5. We need to repeat this step as in step 6, so we need to take each of the corresponding list. So 0, 1, 0, 0, 1. So this is 2, 1, 3. And then add to the relevant parent number, so to the 9th, which means it will be 11, 10, 13, and 12. Same thing applies for each individual button. So 1, 0, 1, 0, 1, which is 3, 4, 2, 1. We're adding this to 10, so that will be 13, 14, 12, 11. 0, 0, 1, 1, 0 will be 1, 2, 3, 4. That'll be 8, 9, 10, 11. And then for last, 0, 1, 1, 0, 1, which is this one, 2, 4, 3, 1. So that means it's 12, 14, 13, 11. So this will be our starting for each of button. And then we'll take the last 32 bits. You should have them. And we can double check this. As you can see, we have 32. We need to divide them groups of 8, which I have already done. And we need to repeat step 7, which means I need to repeat like this. So we take number in every 8 group, and we divide it into pairs like this. Convert each number into decimal ones, and then add 1. So that will be 2, 1, 2, 4, 2, 2, 3, 1, 4, 1, 1, 1, 4, 1, 2, 3. And then we're gonna simply add each one of them to the end one. We don't need this anymore. I can remove it. So it'll be 13, 11, 15, 16, 2, 1, yeah. Then for this one we have 15, 16, 15, 12. We have for this one 12, 10, 11, 12. And for last, this one we have 4, so 16, 15, 15, and 14. Now let's check. So we don't need this anymore. So we're gonna press 4, this one, then 5, 6, 7 on this. Now we're gonna press on 8 only this button, then 0, 9. We're gonna press on top left and top right of the bottom left. Now 10 will be interesting part because I'm sorry, I forgot I need to increment this. It's still correct, as you can see. There's also 10 in this one. I believe that's it. Yes. So now we increment this by 1. So 11, which means we're pressing this, 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 and that. Increment by 1. So 12. These 3 and these 3. Now 13. These 3 and this one. Now 14. These 3, and then 15. And for the last 16. And this is how you solve the module. Thanks for watching, and make sure you don't explode.